Hello again, geometry students. So we're going to continue reflections and rotations. This is part two. In the previous video, we discussed reflecting figures across the x and the y axis, and we looked into what happened to the coordinates of those, and we saw that sometimes the x stayed the same and the y changed sign, or vice versa. In this video, we're going to see what happens when we reflect points across the line y equals x. So let's jump right in. We're going to tie this to rotations as well. So when we reflect across the line y equals x, first of all, this dotted line right here is y equals x. So this is slope-intercept form, slope of 1, up 1 over 1, y-intercept 0. So this is y equals x. We're going to reflect this triangle around, or across, I should say, this line. This is our line of reflection. So I put a note in here. I would just choose a point on this line. I'm going to just choose this one right here. That's the point that I'm going to use to kind of figure out where exactly everything's going to be going. So I'm going to start with C here. C is just 3 units to the left of this. Okay, so 3 units to the left. When I reflect it, it's actually going to go 3 units down. It's going to end up over here. Okay, so basically 3 and 3. It's going to end up right there. O, when I reflect point O across this line, you can kind of see it goes diagonally across one square. It's going to end up right there. Now for T, it's hard to tell exactly how we get there. So I'm going to go up 1, 2, 3, 4. So I'm 4 units away in this direction. So that means I'm going to be 4 units away in this direction. And then it's 2 to the left. So 4 units this direction. And then down 2 like this. And that just kind of gets you an idea of where to put everything. And it also helps if you can just kind of visualize where it's going to go. Let's label these things. So this was C prime, O prime, T prime. Let's draw in the sides here. And always good to double check and just make sure that it actually looks like a reflection across that line of reflection. I think it looks pretty good. Now let's actually put the coordinates here and we'll see what we notice about them. So C prime is at 5, 2. O prime is at 6, 4. T prime is at 9, 9, 3. So what do you notice? Take a minute and answer that on your own. Pause the video, take a minute. Well, I notice same numbers. It looks like they're just switched around, right? So it appears that a reflection across this line y equals x just changes the x and the y coordinates. So the x and y coordinates interchanged is a good word for it. X and y coordinates, they change spots, I was going to say, but interchanged is probably a better word. X and y coordinates interchanged after the reflection. So again, we've talked in the last video about an ordered pair rule. So when the pre-image is reflected across the line y equals x, it just interchanges the x and y coordinates. So here's a good summary of what the ordered pair rule would be. So the actual ordered pair rule when you reflect across the line y equals x would be this, that the ordered pairs transform into y as the x coordinate, x is the y coordinate. They just interchange x and y there. And this next thing, this is actually an animation in AgileMind. This is just going to relate a composition of two reflections across the x-axis, then across the y-axis, and you're going to see that it ends up being the same as a 180-degree rotation. So I put this figure on here. I just used a square. You can use the other ones in AgileMind yourself and test them out. Here are the coordinates of it. I reflected it across the x-axis, so here are the new coordinates after that reflection. You can kind of see what we saw in the last video with those coordinates. Then I took it and I reflected it across the y-axis, and it ended up right here. And then I had it show me the rotation. So we're talking from this one. We're calling this the original, the pre-image. This is the image. Watch, and you'll see in the animation that is the same as a 180-degree rotation. So just to summarize, we saw the ordered pair rule with a reflection across the line y equals x. All that happens is that you interchange the x and the y coordinates. When you do a composition of reflections across the x and the y axis, that is the same as rotating around the origin 180 degrees. So we can really say we can apply this ordered pair rule, or kind of a composition of ordered pair rules, to learn about what happens when you rotate something 180 degrees about the origin. That's what they're doing here. So they're saying B to B prime would be reflecting it across the y-axis. And then they did another reflection from this one across the x-axis. Okay, so across the y-axis, the y-coordinate stayed the same and x changed sign. Then when we took this one across the x-axis, the x-coordinate stayed the same, but the y-coordinate changed. So as a result, just to sum everything up here, starting with the original, this green one, to after the second reflection, that is the same as a rotation. And here's what happens with the ordered pairs. You can see that what happens is the x and the y coordinate both change sign. Here it is summarized as an ordered pair rule down here. So you will start to see this notation a little bit more frequently in regards to rotations. Now, next, I'm gonna check just some understanding. We'll do this in class, but I'm gonna use this to check some understanding in class. So I'm not gonna go through it right now, but we will do that in class just to kind of summarize all the different types of transformations, reflections, rotations, reflections across the axes, and y equals x. So we'll do that in class. But this talks more about a different type of reflection across a different line of reflection. It also ties in rotations to a composition of reflections. And just like the last video, gives us some rules as ordered pair rules, and that different notation. So I hope that is helpful, and that will finish this part of topic 3. Have a great day.